Well, welcome back to Mine Operator. We are here in Southern California prospecting for uranium. We got Jason from Mount Baker Mining and Metals with us. Thanks for flying down.
Absolutely. I'm happy to be here. I'm excited to do some rare earth and uranium prospecting, use your XRF a little bit, and just learn how you guys do it down here.
So we're going to show you around this property and where we're finding rare earth elements and uranium minerals. So Jason put us to work at his mine. Now we're putting him to work fixing a road out here.
Yeah, turnabout's fair play.
Now we got to repair this road so we can get up to a rare earth element prospect. So we're going to go exploring. It is awesome having Jason out here with us today. It was pretty exciting to be up there at his property and mining for gold. Now we have him out at our property helping us prospect for rare earth elements and uranium. Totally different type of prospecting, but there's some similarities and it's an absolute blast. So we have so much to show you guys as we are on some gnarly roads in the California desert, and there's a lot of drill pads and caps to old drill holes. So can't wait to show you what we find. This is absolutely nuts. This road has gotten washed out horribly. It's like I'm rock crawling. Wow. I don't think I'm going up that. This is as far as I go. So Ron, you and I survived that bedrock climbing. That was brutal. You know, it's hard to show on the camera just how rough it was coming up, but we're rock crawling in our rigs.
And it was very, very steep. It was kind of bouncing.
Yeah, there are some pretty large boulders. Even this section right here.
This looks good compared to down there where we just drove over.
So, but it's very difficult to turn around up here. So we figured we're just gonna walk it. Here comes Ron, making the trek up.
Yep.
And look at that gorgeous view.
So here we've got a piece of rare earth. I don't suggest you lick these rocks. A lot of people like to lick rocks. See if it's gold. It looks like gold, but it doesn't taste like gold.
Yeah, see, with the reflection in the sun here. There's a lot of mica in here. This is basically an altered pegmatite dike that the rare earth elements travel in. And over here is where it came from.
I have some good news to report. I found my lucky magnet that I left here 2 years ago. When I first started prospecting, the first time I went metal detecting, I found this, and it's been with me ever since. And I left it up here for 2 years, so I got it back. So maybe we'll have some luck this year.
That just shows your skills as a prospector has really improved over the last couple of years.
All right, so what we're looking at here is a large pegmatite vein that runs east-west. And we have our pegmatite, and then this mica-looking material that's been mineralized on the hanging wall and then proceeds, you know, this direction in the vein, and it's got a whole bunch of different stuff going on with it. And we've scanned it all the way out, maybe 20 feet, and still get trace rare earths, but majority of it's here. So we're going to use the Vanta today to check out our little hot spot. And the way that we would always prospect out here before we had an XRF was with like a Geiger counter. We had to use the Geiger counter to try to find our stuff. So I'll turn the audio on. So just background chatter, and then once we start getting into the hotter material, we start getting into higher counts. And then once we start seeing things over like 1,000 counts per minute, we start prospecting that stuff. And then the hottest this spot really gets is around 3,500 counts per minute. So I'll turn that off for those of you that can't stand the clicking noise. We remember your comment, so we'll turn that off. So this spot we prospected before with the old XRF that we had, and we sent that in for assay. So we're going to repeat that same test with the Vanta and see how close we can get to our past results.
And we were getting around 1% rare earths, right? It was half to about 1.5%.
Yep.
And that was chemical assay.
Mm-hmm.
So we use these tools to help identify which samples to send in for chemical assay, right? For confirmation.
Yeah. So this will, I'll shoot the rock with this thing and it'll kind of give us a rough idea of what we're dealing with, but a better way to determine the mineral content is just to grind it and send it in for assay to get a better idea. Just shooting the face of the rock is not going to be a true testament to what's in the rock, but it's a good start. And every trigger pull is like $40 to $60 in an assay, so we'll do like 200 of these in a day, and can't bear to do any more. And that, I mean, what's the math on that? You know, you're talking $800 to $1,000 in assays in a day.
The XRF pays for itself pretty quickly.
Yeah.
If you are exploring out in the field, this is definitely a tool to have in your arsenal.
I can check the elemental suite, and it tells me which beams do what elements, and that's really exciting because now I don't have to sit there and memorize things. And the Delta, you can do that, but this one, it's like I touch it, it goes there, and then I got 3 different beams.
So what's awesome about those beams is if we want to spend more time testing on beam 1 or beam 2 or beam 3 based on the element suite, we can elect that in this XRF gun.
Yeah, definitely.
Right?
So I've got the first and third beam set at like 30 seconds. I don't need that much fidelity because I'm going to set it in for an assay. I just want to know, like, off the bat, because every time I pull the trigger, it's a minute and 30 seconds of my life sitting here enjoying the wonderful outdoors. But after about 200 times, it gets kind of old, so you want to start going faster. And so I got through the first beam, and there's iron, titanium, and barium, and manganese are kind of the main players. Yttrium already showed up, and it's not even looking for it yet, really. So what's nice is now we can see potassium. So now we were reading about potassium and the pegmatites and the potassium carrying the rare earths. That's like 4%, dude. That potassium's radioactive too.
Wow.
It's on the tree of radioactive decay, right? Do you know where it is? And it's like it goes like uranium, thorium, and then like 20 other different elements. And then you end up with lead at the end, you know?
Yeah. So
that radioactivity isn't just thorium, it's potassium. All right, let's see. So cerium, we're at 1900. This is all parts per million. We got neodymium. The last with the delta, we couldn't see a neodymium, so that's exciting. Latvium, there's phosphorus, and then thorium at 570, which is...
Well, I'm real happy to see 1,030 parts per million of neodymium.
Yeah.
That's one of the most critical rare earth elements. I forget if that's a heavy or a light rare earth
What was
element.
TE again?
TE? Tellurium?
Tellurium?
Yeah.
Tellurium here. Cool. That's a first. We didn't really start seeing scandium until we got on the uranium side of things, right?
Yeah.
Did you shoot right where where we drilled the holes?
Yes, sir. It came back around 5,000 parts per million total with all the, just quick math.
All the goodies?
Yeah. So we're moving away from the hanging wall. We're already getting kind of lower values in some of the elements in this spot. So yttrium's still there, so we'll see what happens in the second and third beam.
Do you recall if the second and third beam is where most of what we want to see shows up? I forgot.
It's the third beam.
It's the third beam.
Yeah, so I had the third beam. It was defaulted at 10 seconds, and I put it at 30 just so I could get my error rate down a little bit so I would believe it. Yeah, so even the potassium out this far is still going. Yeah, so yttrium is at 500. Yeah, so it picked up the latvium about 4, just under 500.
Yeah, okay, lanthanum.
It seems like the neodymium is hanging up more towards, yeah, see there it is. There's the neodymium.
Well, 470,
it's still bouncing
520.
around.
Yeah, climbing.
Yeah, so this is like the percent, it could be, or the parts per million could be off. So it's seeing 470 parts per million, but then 280 error plus or minus.
Okay.
So that's still good, it's there. So I want to get a better idea. So I'm going to drill the rock and then scan it again. All right, we're running. All right, so remember how we got yttrium at like 2,000? Now it's at 3,500, so finally divided. Now I'm already getting
Shows
higher
up
readings.
more.
Okay.
So instead of going to the surface that's been oxidized, see the problem now, thorium's at 1,200, and I got thorium dust all over my hands. But
Finger looking good.
yeah, don't do that. So we're in the first band and we're already getting high numbers, so I'm excited for the third beam. All right, so right away, calcium and potassium are kind of a big deal in there. Yttrium is at 3,500, cerium's now at 3,000, so we're already at 6,500
Wow,
parts
look
per million.
at that. Lanthanum.
Lanthanum. I was calling it lathium. It's lanthanum.
Lanthanum.
I'm not a geologist. I can mispronounce those. Neodymium, and then thorium.
Those are some great readings.
Praseodymium.
Praseodymium.
Sorry, no
432.
scandium. Sorry, bud.
And if you get DY, let me know. Dysprosium.
And then TE, right? Is that our Thulium? 25 parts per million.
You're getting silver too, huh?
Yeah, but that's like crustal. That's like not a big deal.
That's 12.
Yeah.
Yeah, I saw it was 10 before.
If you see 1,000, then maybe give me a call. I'll come and take it from you.
That's what he just did.
So we're gonna grab some of these samples, right, and list them on our eBay page and sell them.
Right. Yeah, and we're getting the higher value rare earth pieces. Like this one came in pretty high. I don't recall the exact parts per million, but
Those are on 3,500, 4,000 combined.
right.
So if you're interested in collecting rare earth element specimens, we'll have them on our eBay page. All right, guys, ready to get in the crosscut?
Yes, sir.
Let's go find out where that pegmatite dike intersects this crosscut, and we can use our XRF and Geiger counter underground.
Do it.
Just by clicking.
Want me to carry that for you?
Yes, sir.
All right.
Holy cow!
Look at it all.
Yeah, there's some real
Oh, that's
Holy cow!
that is awesome.
Look at the manganese fans on that.
That's very cool.
copper, 2.5%.
Oh, he's trying to see it.
I'm gonna scratch a penny up there first so you can see.
There it is. Oh, I dropped it. There it is. There it is. There it is. So 5 and 4. So there's 1 part per million gold. Now it's 5, 5. Now it's not there.
Just like I had.
Percent out of that.
Yeah. So 3.2% on copper up there.
We're getting a little bit of cerium and lanthanum. I'm never gonna get that one right. All right, it's done. Ugh. Okay, what do we got?
Are you getting any mine operator out of that?
You know, I think we might be able to discover a new element. And then okay, now I'm pretty sure that's calcium. Before I'd be like, I have no idea what it is. It could be any salt. But
Right.
you scan enough, you start to see, like, okay, I know it's a chance it's that mineral. So you don't have to guess as much. Calcium's at 18%, so that definitely is a calcium. Cerium showed up, and then dropped it. Oh, it's back.
What's neodymium?
420.
Okay.
So it's still in that. So this little offshoot carried it.
Which, look, it's actually a contact.
Yeah.
Here's the dike.
Yeah, you got 2 different rocks on either side.
We made it out.
Yeah. That was fun.
We'll get some lunch.
One heck of a view. Now to head over there towards Uranium Hill.
All right, here we are in Southern California in the Mojave Desert, and we're out here prospecting. Wait, what is that? Look, come look at this. Quick. It is in his natural environment. It's a geologist. Look at him. What's he doing? We never see these out here. Gotta be very quiet. They're easily startled. There's two of them. Oh my god. Let's see if we can get a closer look. Oh, there's two of them. Oh my gosh, there's two bloody geologists out here. They're talking. I bet they're talking about rocks. Hey, he's arm waving. They like to arm wave. Oh, he's touching his face. He must be thinking of a theory. That one in the black shirt seems to arm wave more than the other. Oh, I think he sees us. No, no, he's just looking at rocks. Alright, now be very quiet. We're right up on them. They don't know we're here. I think they're talking about geology again.
Hey, we invited Dale out to join us out in Southern California. What do you think of the weather out here?
Yeah, I love the weather out here. You know, I came from Bellingham, Washington, where it rains all the time, so it's pretty nice. You can see the rocks and maybe get a little sunburn.
Yeah, absolutely.
We're making good progress. We're on it day one today, and
Okay.
just getting our arms around it. And really what we did here is we started off on the north end of the claim boundary, and we're just, as we walked to the north, just, you know, got a good look at all the rock types and got comfortable with them and on the same page with Ryan Johnson, who's out here helping me. So we're working our way back to the south, but what we found on the north end, which I don't know, I think is pretty interesting for the project as a whole, is what looks like a pretty reasonably good sized structure coming through, like kind of near your guys' claim boundary and really in that saddle right there. And you can see the saddle off in the distance. You got one there, and you got another one, a big one over there off to the right in that high point. I'm wondering if this gulch here isn't related to a structure that's either making one of those saddles or both, and cutting off the rocks on the north end of the project overall. So that's kind of the first thing that jumps out to me. There's a lot of these structures that come through this area, you know, some of them can be strike slip or have a big strike slips component.
Okay.
So like if you're picking up some, this is big time arm waving here. If you're picking up some, you know, radioactive activity over here, it could be related to one of these big structures that's coming through this gulch.
Okay.
So yeah, that's definitely a possibility.
We're gonna go prospecting and see what else we find. We're gonna try to do some mineral identification, see if we could figure out if we've got some uraninite or autunite. And I was doing a little research, and it seems like autunite is a leached or altered mineral from uraninite or possibly pitchblende, and that I guess autunite is the one that fluoresces primarily. So yeah, we have that all day long.
Yeah, secondary, you know, that's one of the things. It's got that kind of greenish yellow kind of boogery color. Those are for the most part the secondary uranium minerals, autunite, zibiatites or something like that, uranoopilite, I think, something like that. Yeah, and then uraninite and pitchblende, you know, pretty much dark gray and
all right.
different.
Don't forget the leverites.
Don't forget the leverite.
Leverites.
You're right there.
Yeah. Yeah.
So Ryan, you work with Tamarack Geo?
Yep, Tamarack Geological Services.
With Dale, and so they're out here doing some mapping for us. We're hoping to get a neat 3D model that we could spin around and understand what's going on here.
Yeah, at least get a better perspective or an idea of, you know, what's going on based on the previous drilling. You know, we'll put that data in there, the assays with that, maybe define some more coherent boundaries rather than just surface, you know.
Yeah. Any other thoughts or recommendations for prospectors out there?
Just do your due diligence and like make sure you just research a lot. You know, a lot of deposits can be modeled after other similar style deposits, and that can kind of guide you in the right direction. If you're seeing similar trends, maybe it'll point you, you know, somewhere where you can more accurately allocate your time instead of wasting it on things that may not matter. You know what I mean?
Good point.
So there's a lot of resource out there that's just like free and available, you know, rather instead of just punishing yourself going out there being like, well, what am I doing? Quite a bunch of stuff here. I figured bibs are the best for tools. You know, I can store my map case here.
Yeah.
If I'm out scrambling on rocks, or I got my notebook here. Got my GPS, you know, got my UTM coordinates handy so I can find myself on my map here.
Copy.
And You know, I got some special drafting tools that I've acquired over the years. Comes with experience, you know.
Okay.
You watch other people do it and you're like, hey, I like that. So
That's true.
got that. Got my scriber here. Go scratch rocks.
Okay.
Probably one of the most important tools for a geologist. It gives you an idea of hardness.
All right. Okay.
Yeah,
Yeah, I
what
was
minerals
brushing
you're
up
looking
on that this morning, just trying to get a better understanding of what we're up against here with the minerals
Yeah.
identification.
And then, you know, got all my color pencils on here, my scale ruler for my map. This is what I use for photos. So every time you take a photo, it's nice to use a scale
Yes.
and a north arrow if you can.
Okay.
You know, at the least like a scale or like a pencil or something. It's just standard procedure.
Copy that.
Being professional. And then, yeah, hammer, my Brunton.
Gotta have that. Absolutely.
I don't know if many people are familiar with Bruntons. It's a great tool. You can do a lot with it. So you'll measure a dip, which is like the angle it dips from the surface, you know, and then you do that by using this clinometer here, this little tool. Gives you little degrees.
All beautiful. Copy
It's
that.
got a level there. And then you got your compass here, so you can get the strike, so which way that structure is trending, or like an orientation of it, or a bearing. And then you can plot it on a map in real space.
All right.
And another note is safety is top priority always.
Yeah.
Seriously, you never want to get a piece of quartz in your eye, or, you know, if you're going into old adits or anything, make sure you got a gas detector. You never know what could be lingering back there. Hard hat, you know. It sucks to get hurt over something so silly.
Yeah, that's true. And a little prep goes a long ways.
Yeah.
All right. Well, cool. Thank you, Ryan.
Thanks, man.
Take a look at this view. This view is absolutely awesome. Awesome view. What we're doing is we're recording the GPS coordinates for each of the drill caps on the property. And there were drill pads made back in the 60s, 1968, 1974, 1977, and quite a bit of work done out here. From prospect pits to drilling. We want to get an updated technical report. So looking at my topographic map, we are at drill hole number 7. And I'll have to reference that later when I have the map up of the core drill log. Notice the yellow-green material here that is soft, and notice the dark material behind it. I want to use the microscope on my phone, and I want to zoom in and be able to see what these minerals look like up close. So the book I have here with me to help me out in the field today is Uranium, Where It Is and How to Find It by Proctor, Hyatt, and Bullock. So on page 8, under primary uranium minerals, Uraninite is similar to pitchblende in most of its physical properties. However, it occurs in the form of small cube-shaped crystals rather than rounded and irregular masses. The other primary minerals of uranium are not known to occur in large enough concentrations to be important. Notice under secondary uranium minerals, autunite is a bright lemon yellow material. It is soft and occurs in small, flat, and translucent crystals. It always fluoresces to a bright yellow or apple green when exposed to ultraviolet light. Just a little bit longer and it'll be getting dark. This is the view out of the portal. This rock that we're using the XRF to take an assay of was blasted from the face up on the hill. We stumbled across it and noticed the bright yellow-green autunite material and decided to use our XRF to take an assay. We also send samples off to the lab to get a chemical assay to back up those XRF assays that we got in the field. The Vanta XRF has lots of bells and whistles to help us work smarter in the field. One thing that we like is the customizable display. so you could hide any elements that you don't want to see or bring up the most important elements to the top, regardless of the concentration. Another thing that we learned is there's formulas on there, so you could sum up all the rare earth elements that we received in our XRF assay and display that total concentration, which would really help us. You can also use the yttrium concentration to predict the total rare earth oxide, which is a really neat feature. We got a staggering 18% uranium assay at this location. The uranium was so high at this location it actually affected the XRF and showing high gold and palladium values that aren't really there. If you crush this rock down and mixed it, it would probably come in far less than that though. Somehow I accidentally had time lapse on when I was shooting this portion of the video, so I missed out on some good audio. Harry is using the shortwave ultraviolet light to get the minerals to fluoresce. So if you're using a black light, which is a long wave light, you may not get the same fluorescence that you're hoping for when you are prospecting at night. Be careful though with the shortwave light, as it can damage your eyes. The whole team here at Mine Operator wants to thank Tamarack Geological Services, Dale, Ryan, and Art for coming out and mapping the structures here at our property. We look forward to the 3D model that your team puts together, along with the technical report that you guys write. Thanks for coming out. We also want to thank Jason from Mount Baker Mining and Metals for putting us in contact with Dale at Tamarack Geological Services that helped make this possible. Be sure to check out Jason's channel as he put together a video for prospecting for uranium and rare earth elements as well. Thanks for watching and stay tuned as we're going to post the 3D model that Tamarack Geo comes up with on one of our future videos.